In this video, we're going to be problem solving using linear modelling, which we have targeted through previous examples. This is now looking at a problem, a word problem I should say, and we're expected to solve it given a limited amount of information. Now this is a two-part question, part A and part B. And the question reads, a taxi fare charges a $2 flag fall and $1.50 for every kilometre driven. Question A, create a graph illustrating the relationship between price in dollars and the distance travelled in kilometres. So what we have to do is create a graph illustrating that relationship for the information provided. So what we have is a y-axis and an x-axis, and what I've done on the x-axis is I've labelled it as distance in kilometres and the y-axis as price in dollars. The reason I've done that is the x-axis is my independent variable. Okay, now distance is independent of price, which means price is dependent upon distance. So we keep our independent variable down here and we put our dependent variable up here. So price is dependent upon the independent variable distance. I've also labelled them as an x and a y, just to help with the coordinate structure. Once I did that, I put a point at the 2 on the y-axis for the price, because that's indicating a $2 flag fall, which is what they suggest in the question. So the $2 flag fall means that when you get into the car, having travelled no distance whatsoever, when you get into the taxi, you have to pay $2 without having travelled any distance whatsoever. What I then noted that was that for every kilometre driven, you have to pay $1.50. So for every kilometre, we're going to have to pay $1.50. So after 1 kilometre, on the x being the distance, after 1 kilometre driven, we need to increase this point by 1.5, being $1.50. So if this is 2, we've got $3 and $3.50, which is why this cross is located at $3.50 after 1 kilometre. So we've got the $1.50 for the 1 kilometre plus the $2 flag fall gives us the $3.50. I then went another kilometre across and added another 1.5, another kilometre, another 1.5, another kilometre, another 1.5, and another kilometre, another 1.5. I then joined all of those points with a straight line, and the reason why I did that is because I'm going to have to determine this equation, or I'm likely going to have to determine this equation, which will explain the relationship more clearly between price and distance being the x and y variables. Part B reads, determine an equation representing the relationship between distance and price, which is what I just suggested. We're going to have to calculate an equation from that particular problem, or from this graph I should say. So we're going to calculate the equation of this straight line. To do that, I need to define my general form for a straight line, that is y equals mx plus c, and I've called it equation 1, so that if I want to refer to that later, I can just refer to equation 1. I've then gone about defining the gradient, or the slope m, for this formula, and what it's equal to, and how I can go about calculating it. I need 2 points, or 2 coordinates, to substitute in here. I need a y2, a y1, an x2 and an x1, which I'm going to get from these 2 points. Okay, what we have up here is essentially a y2, and we've got an x2 because that's the second point, and down here we've got an x1 and a y1. So I'm going to substitute them into this formula, which will give me 8 take 5 divided by 4 take 2, which simplifies to 3 on 2, which as a decimal is 1.5. I can then substitute that m value of 1.5 back into equation 1 to give me equation 2. Okay, the only difference is m now, I'll put 1.5. We'll see that c is still unknown, which means I'm going to have to calculate c, And that's what we're going to be doing over the page. Now it says sub xy coordinate into equation 2 to solve for c. Now the coordinate I'm going to use is 2 and 5. That coordinate I got from the graph here, coordinate 2 and 5, and I've substituted it into this equation, equation 2. And when I do that, I get this. I put 5 in place of y and I put 2 in place of x, and I simplify this expression here, which is 1.5 times 2, which gives me 3, and then rearrange to solve for c to get 2. I can then substitute that c value of 2 into equation 2, which is this one back over the page. So I'm going to substitute 2 into here, which is equation 2, and it will give me the equation. Now that is the equation with reference to x and y. Now to put it in a form of price and distance, so that we're relating the price and the distance of this taxi fare, we're going to have to go back to the graph and quickly see what the y-axis is referring to. So we see that y is referring to the price. So where I see y, I can put price, and the x is referring to distance. So where I see x, I can put distance, which gives me this here. So where I found y, I put price. Where I saw x, I put distance. And I've shorthanded that to p equals 1.5d plus 2, where I've then defined what these variables p and d refer to, being p the distance, and p the price, and d the distance. And we have a equation representing the graph.